Hi guys, welcome to my YouTube channel. Today we are going to be looking at the Southwest Regional Mock question number 1. This is the third episode I'm presenting on the paper. So if you are new to the channel, kindly go back to the channel, look at the content and watch the previous episodes and you'll be blessed. You will learn a lot from them. So don't forget to subscribe as you watch this video, and after watching make sure you share the video so that it can go viral and also encourage me to continue creating such content for you guys. So I am Temgum48 presenting this script. Without wasting much of your time, let's get into the solution proper. So we begin with the very first question, the question on polynomials. We are told that the zeros of the polynomial x cubed minus 2x squared minus x minus 2b's are a, b, and a plus b. Determine the values of a and b, 6 marks. So recall, this is a cubic polynomial. When things are easy, please let's keep it simple. There are many ways you can approach this question, but I'll provide to you the simplest approach that you can take. And also, another person might take another method which maybe coincides with this one, but I will not present all those methods here. I will just present one method here. If you need the other methods, you can just comment in the comment section that I need it. Then I will show you the other approaches to the problem, and you end up with the same result. So recall that for a cubic polynomial, ax cubed plus bx squared plus cx plus z equals to 0, if the roots are alpha, beta, and sigma, then it means that the sum of the roots will be negative b over a, just like what you have for quadratic equation. And then the product of the root alpha, beta, I made a mistake here. So it was supposed to be sigma here. Anyway, that can easily be corrected. So the product of the root, that's the three roots, will be what? Negative d, that's the constant term, negative of that divided by the coefficient of s cubed. Then now, the pair sum, this one is called a pair sum, is c over a. Pair sum means you pair up, that's you multiply them. That you can see alpha and beta, they have been paired up. Beta and sigma, they have been paired up, and alpha and sigma have been paired up. So you pair up the three terms, these three form possible pairs with them, 2 2. Okay, that's why I call pair sum. A pair means two things involved, right? Yes, so it's actually c over a. So we're going to use this notion here to answer the question. So using that fact, let's first of all call our function a polynomial f of x to be that. Then now we have that the sum of the roots, which we say is negative b over a. B is the coefficient of what? X squared. And the coefficient of x here, that is negative. The sum of the roots, you have a plus b, which you are seeing here, plus a plus b. Yes, these are the three roots. The sum of the three roots is equal to negative b over a. My a is 1 and my b is what? Minus 2. So I have negative into negative 2. And when I simplify this, I end up with 2a plus 2b is equals to what? This one will give us 2. And then dividing all through by 2, as you can see, is a common factor throughout. It gives us a plus b equals to 1. So now, that is the sum of the roots. Now, for the product of the root, that's when you multiply the three roots together, a times b times a plus b, it is exactly equal to negative d over a. My d here is what? The constant term, negative 2b. So AB into A plus B, that's the product of roots, is negative into negative 2B over 1. That's applying the formula, right? Negative D. My D is negative 2B. That's why I have negative negative. The negative sign is this one, that first of all there, then minus 2B over 1, since A is equals to 1. I'm talking with reference to this general format. So when you simplify that, we have the following, that this is equals to what? 2b, because a plus b is equals to 1. I've replaced that in this expression. So since a plus b is equals to 1, without wasting much time, I recognize that and I replace. So I have 1 times ab. I have that. Then now we now move all the terms to one side, giving us ab minus 2b equals to 0. When you cross the equality sign, the sign equally changes. Now from there we factor out our b. That will give us b into a minus 2 equals to 0. So we have either a equals to 2 or b equals to 0. Now with that, with this now in mind, so we now take different cases. Case number 1, when a equals to 2. When a is equals to 2, we solve for b in this equation. B will be what? 1 minus 2, which is negative 1. That's a possibility of the values of a and b. That's the first case. Then now from this, now we will have our polynomial to be x cubed minus 2x squared minus x. Then since my b is minus 1, when I replace minus 1 here, it gives me plus 2. I keep that aside. Now also from this, now following this definition that was given there, since a is 2 and b is minus 1, the roots will be what? A, b. So 2 minus 1, and the sum of the roots will be what? The sum of a and b is what? 1, right? So that's 2 plus negative 1, 1. Now when you do that, we take the second case when b is equals to 0. When b is equals to 0, we will end up with what? When b is equals to 0, we come here to this same equation and replace our a and replace our b equals to 0 there. We end up with a equals to 1. So having that in mind, we have that our polynomial will be x cubed minus 2x squared minus x, and now our roots will therefore be what? 1, 0, 1. But there is no possibility of this polynomial, this second case, the polynomial f of x there, it can never have a repeated roots. You can watch my I'm bringing up a series on solution to equation. Make sure you subscribe to this video so that when I will start uploading that content on that, because I will explain that detailedly, make sure you subscribe so that you'll be notified when I start uploading those content. Now if you test, because these are zeros to this polynomial, 0 satisfy, good. What about 1? Does 1 satisfy? 1 minus 2 minus 1. Is it a root? No, it is not a root. So in this case, this combination of a and b here fails, right? So just by testing, it shows that 1 is not a 0 to the case 2, right? As you can see. Hence, we can go only for case 1, because if we test 2 in this equation, we end up with a 0. When you test minus 1 here in this equation, you still end up with a 0. And also when you test 1, you end up with a 0. Also, you can factor by grouping. You group this first and you group this second and factorize it. You end up with 3 factors which can easily be identified to be this as zeros. Now that is what we are supposed to do. So our correct answer is a equals 2 and b equals to minus 1, 6 marks. So there are, like I said, there are other approaches to this problem, right? But for this video, this is what I'll be presenting. If you need the other approaches, you can just comment in the comment section and I'll drop maybe I'll interact with you and look for a means to send it to you if you need it. Now that is all what you need to do for question 1. So let's get to question number 2, as that's the Roman numeral 2 of the problem. You are given two quantities x and y, and you are told that they are related by the law of this form. We are asked to linearize this relation and state the gradient and the intercepts. So we first of all begin with our expression. Now, when we have something like this, what makes it not to be a linear form, being linear form, is this power of n here. So the very first step is to take the logarithms. You can take ln on both sides, or you take log to the base 10 on both sides. In as much as it simplifies the problem, cool. So I decided to take ln on both sides. When I take ln y equals to ln a into x plus 2 raised to the power n. Now applying laws of logarithm here to the right hand side, that will just be a product, right? So this is just this is a product, so you can replace it with a sum of these two logarithms. So this is ln a plus ln x plus 2 raised to the power n. Now see, apply laws of logarithm here to this second term on the right hand side. We will see that this thing here, the power will just drop and we end up with something like this: ln y equals to ln a plus n ln x plus 2. Now this equation resembles the equation of a straight line: y equals to mx plus c. Y equals to mx plus c. Just wait. So we have something like this: y equals to mx plus c. Oh, it's not the best. Let me just erase that. So we have something like this: y equals to mx okay. It is not an easy task to write with a mouse. Okay, now this is how so this is my y here, this is now my x, and what is here is the gradient. So that looks nasty. Let me just erase everything. Going back to our presentation, so from here, plotting a graph of ln y against ln x plus 2 gives us a straight line whose gradient is n and the vertical intercept, I insist, vertical intercept, it's just like intercept is wrong. The vertical intercept is ln a, because when you plot your graph, right, we are interested, when we talk of the intercept, we are talking about the vertical intercept. When you just see the y-intercept, it is wrong, because you can label your graph paper anywhere, anyhow you want it. So just saying that the y-intercept is automatically wrong. It's rather you see the vertical intercept. So that's a little maybe correction I can make to this problem here. So this is what you're supposed to do for 4 marks method 2 accuracy 2. Okay, so this is the end of this question paper. That's question 1. So I would like to see you guys in my next tutorial. Bye bye, stay tuned.